So we're graphing quadratics. Simple graphs are three things. And I mentioned them on Friday and Thursday, actually Thursday of last week before we went on a break. You remember what the simple graphs are made of? We need to graph three things. They need to remember. Good. The x-intercepts. That's the first thing. Second thing, the y-intercepts. The third thing, the vertex, and we're done. The final three things, we graph the parabola. Okay? I typically do this one first. I typically get the vertex first, and then I get the x-intercepts second, and then the y-intercepts third. It doesn't matter, though. I like doing this one first. But the point I'm trying to make right now is this. When I ask for a simple graph for quadratic, I'm asking for those three things. Okay? So, let's look at the warm-up that Ponce did. Let's see if he got it in the vertex form. So let's see. He added b over 2 squared. So he took b, 4 divided by 2, squared it, and that ends up being 2 squared. That becomes 4. So that's why he added the 4 right here. He added that 4. But then he immediately subtracted the 4. So if you add 4 and subtract 4, you're really not doing anything to the equation. To the right side, actually. So at that point, you factor the trinomial. X plus 2 squared looks good to me. You combine the negative 4 plus a 3. That becomes a negative 1. And now we're going to compare it to vertex form. Is it in vertex form? Let me get vertex form right here. Let's compare it with this. So remember we worked on this last week. So let's compare it with vertex form. Looks very good to me. So we have a, in this case a is 1. X, we got the x, we got a minus h. But we have a plus 2. So this is really, we went over this last week, this is really x minus a negative 2. X minus a negative 2 is really x plus 2. So if we follow the formula, the structure of everything, we know that the vertex is hk, and h is right here. But it's after a subtraction sign. So we make the plus into a subtraction and make this a negative 2. So h, in this case, did you put that already? You did a, yep. So notice h is negative 2. That's our vertex. K is going to be a negative 1. But this says plus, so we can make this a plus negative. So now the structure looks identical to the vertex form. Negative, we have a minus and minus, and we have a plus here. So hk would be our vertex, negative 2, negative 1. Excellently done, Ponce. So we're done. So we're going to actually use this as our first example today, the one from warm-up. Ponce did it for us. He found the vertex, negative 2, negative 1. Before we start proceeding to graph it, is there any questions on Ponce's work? Anything that's not clear? Now, McKellar, Scott, and I will talk to you guys shortly about completing the square. I'm not sure if you guys were here when we did completing the square, but you guys kind of missed a lot, so we'll talk individually if you're not if, because you guys are lost right now. I understand. So we'll talk soon, okay? But those of you who have been here, any questions on Ponce's work? All right. So the vertex is done. Go ahead and grab your piece of graph paper. Make yourself an x and y axis. Make yourself an x and y axis, like mine, if you wish. Go ahead and make yourself an x and y axis. Got it. So let's plot this vertex. You don't have to when you make your x and y axis, I know where the numbers are at. You know where the numbers are at. Don't bother writing all the numbers down. That's not necessary. Okay, but go ahead and make an x and y axis and let's practice the equation. So let's go ahead and plot that vertex. That vertex was -2, -1, I believe. Let's plot that together. -2, -1. What's that the vertex? I can't remember. Yeah, -2, -1. Right? That was the vertex. Go ahead and plot that with me. -2 and -1's right there. Beautiful. Cool. All right. Vertex is done. Now let's find the x-intercepts. Okay? The x-intercepts. Those of you who were absent on Thursday, I went over what the x-intercepts were of a parabola or a menu graph. You'll have to catch up on those notes by watching the video that I already posted to Google Classroom. But for the sake of those who were absent, do you guys remember what the heck is an x? Let's find the x-intercept before the y-intercept. What is the x-intercept? Does anybody remember? The point where a graph crosses the x-axis. That's the x-intercept. So where does this graph cross the x-axis would be the x-intercept. We know that wherever it does cross the x-axis, y is going to be 0. In other words, let me draw a simple parabola. Watch this. Don't draw it with me. Just pay attention. So look at this parabola. Look at my finger. Right now, this parabola crosses the x-axis at, look at this, right here and right here. Just pay attention. Don't write this down. So the x-intercept here would be 2, 0. The x-intercept here would be 6, 0. There's two x-intercepts. Notice how the y-coordinate is 0 at both points. Notice that. Matter of fact, wherever I move this parabola, wherever it crosses the x-axis, so right now it crosses the x-axis now at -3, 0. Look at it. Right here, -3, 0. Look at how the y-coordinate is 0. And here is going to be -7, 0. Again, y-coordinate is 0. Wherever it crosses the x-axis, the y-coordinate is 0. That's what we went over on Thursday for those of you who were absent. So to find the x-intercept of this equation from warm-up, the one that Bonta did, to find the x-intercept of this equation, this one, we're going to let y equal 0 and then solve for x. We'll have our x-intercepts. So, on your paper, I'm going to write the equation that we have for warm-up. So now this is not on your graph paper, this is on your simple graphs notes. We're going to write y is equal to x plus 2 squared plus -1. Okay, I'm going to write this on your note paper, not your graph paper. So we already know the vertex. The vertex is equal to -2, -1. We already plotted that, right? -2, -1. Now we're going to find the x-intercepts. Find the x-intercepts. Set y equal to 0 and solve for x. Let's do it. So right now you have your graph paper to the side. You're writing down this equation we did for warm-up. We're going to find the x-intercepts. How do we find the x-intercepts? Well, we set the y variable equal to 0, and then we solve for x. The graph paper's off to the side right now. Everyone's writing this down on your note paper. So write that equation down. Right, this will be example 1. So we're using the same example for warm-up, for example 1. My bad. So that's the warm-up example that Ponce did for us. We know the vertex already. Right? Mr. Ponce did that for us. Now we're going to find the x-intercepts. Do it. All right. So notice I'm going to set y equal to 0. Look at, instead of y, I put 0 equals x plus 2 squared plus a negative 1. Right? So let's get x alone now. Notice the variable's right here, and it's in a binomial squared. Let's start proceeding to get it by itself. So I'm going to, so the opposite of adding a negative 1 is I'm going to add a positive 1, huh? Let's get x alone. So I have 1 equaling x plus 2 squared. That's gone right here on the right side. Let's get rid of that second power. Square root to right. Whatever you do to one side, I do the other side. There's a balance, right? Equation. Here we go. That's gone. So I have x plus 2 on the right side. We don't need the parentheses anymore because it's all alone. Square root of negative 1, or actually square root of positive 1. What is it? Whenever time the stuff becomes positive 1. 1, huh? 1 and 1, and negative 1 times negative 1. So this becomes positive and negative 1. Because 1 times 1 is 1. Negative 1 times negative 1 is also positive 1. So we got two roots there. Think logically here. 1 times 1 is 1. Negative 1 times negative 1 is also 1. X is almost done. And isolated, let's subtract 2 from both sides. All right? So, x is, man, this looks weird. You can see it two ways. You can see this as positive and negative 1 minus 2. Or you can write negative 2 plus and minus 1. Either way, it doesn't matter. This and this mean the same thing. But now I've got to separate both solutions out, right? Because there's two solutions. There's a negative 2 plus 1 is going to be our first solution, and then negative 2 minus 1 will be our second solution. All right, so look what I'm going to do. I'm going to separate them both out. Negative 2 plus 1 and negative 2 minus 1. See, I separate them out. There's two solutions here, the plus and minus. Okay. Let's do it. X then is, we got negative 2 plus 1. That'll be a negative 1, huh? And negative 2 minus 1 is going to be a negative 3. Okay, so let's try to remember what we're doing here. We're finding the x-intercepts, which means the point where the graph crosses the x-axis. That's what x-intercepts means. We have our graph paper. right over here. We already plotted the vertex. We're trying to figure out where's it across the x-axis. Well, we know that y is 0. Okay, so what we found here is the x-intercepts. So the points that we're going to plot, look at, remember y is always 0? I just told you that. I belabored that point. So this is the first x-intercept is going to be negative 1, 0, and the second x-intercept is going to be negative 3, 0. So we're going to plot those 2 points now together. Okay. Y is 0, so let's plot them. Negative 1, 0, negative 3, 0. Do that with me on your own graph paper. Negative 1, 0 is right there, and negative 3, 0 is right there. Do that with me on your graph paper. So for the y-intercept, we're going to replace x with 0 and solve for y. Let's do it. Here we go. So wherever I see x, I'm going to replace it with 0. Look at this. 0 plus 2 squared plus a negative 1. Okay. I replaced x with 0 now. Now let's follow Aunt Sally. She says to do what's in parentheses first. 0 plus 2 is 2. Let's keep following Aunt Sally. Exponents now. 2 to the second power. 4. 4 plus negative 1. 3. What have we found? Our y-intercept. And x is 0, right? So the point that we're going to plot, 0 is x, 3 is y, 0, 3. So plot 0, 3 with me on your graph paper. Zero, 3 is right here. Let's make our parabola. Okay, here's our parabola. We've got the vertex, x-intercepts, y-intercepts. We're good to go. What do you guys think? Now, some of the stuff that we're doing here, most of the students at Pomona Unified can do what you're doing now, and we're at Park West. So some of you have come to Park West, the home of the Wizards, perhaps thinking you're going to take classes that are easier or that we're going to dumb it down for you. I'm not sure. I'm not in other teachers' classrooms. This is my classroom. Perhaps some of the teachers, I sometimes get a whiff of some of the teachers maybe dumbing some of the content down, making it Mickey Mouse for you because we're at the home of the Wizards. But I'm kind of getting a sense that you're starting to get the drift that I'm not going to dumb it down because you're at the home of the Wizards. Because I care for you. I don't want to cheat you out of a full, meaningful education, mathematical. I don't want to keep you behind. But in me doing that, there's a price to pay. And the price is you're going to have to stay with me each day and put in the effort. It's going to require some work on your part. Is it worth the price? I suppose we can debate that later. And I'm pretty confident you're not going to convince me otherwise. But we can debate that, I suppose. But I'm not going to dumb it down because you're at the home of the Wizards. I know some of you are struggling. That's cool. Here's my quote. Here's my quote about struggle. This is one of my heroes. I read his autobiography in college, my second year in college, and it changed my life. He was a runaway slave. He never stepped foot into an institution of higher learning at any school. And when I was reading his autobiography, it was like I was reading someone who had a doctorate degree with all the words he was using. Guy's awesome. Frederick Douglass. And look at that quote, where there is no struggle, if there is no struggle, there is no progress. Welcome. Long time no see. They give you this stuff? Yeah. Cool. I haven't seen it anywhere. Good to see it again. So, Let's do one more. Okay, we'll do one more example. I'll release you guys in groups, do a little small little table talk again. Here's example 2. Stay with me. Example 2. Y is x squared plus 6x plus 5. Y equals x squared plus 6x plus 5. Let's provide a simple graph of this one now. You're already doing it. I love that. You're not waiting for me. You're not waiting for me to hold your hand. You guys are trying to do it on your own. I love that. Keep that up. So let's calculate b over 2 squared. B over 2 squared is going to be b is 6 over 2 squared. That's going to be 3 squared. That's going to be 9. Huh? Can you get that, Chris? So I'm going to add 9 and subtract 9. Here we go. Y is x squared plus 6x plus 9. I'm adding 9, but now I'm going to subtract 9 also. This way it evens it out. This way I'm not tampering with the balance of the equation. What do you need? Sure, I'll be right there. Again, I'm not tampering with the balance. I'm adding 0 to the right side. Okay, that's that move that Ponce did in the warm-up. But the fact that I added 9, I now have a factorable trinomial here. Look at this factorable trinomial. I'm boxing. All right, so here we go. Let's factor that puppy. Go and do that while I answer the phone. For you. Yes. Got it. 1 second. Here we go. Let's do it. X plus 3 times x plus 3, right? That trinomial. X times x, x squared, 3 times 3 is 9. Outsides, insides become 6x. That's old news. We've done that like about a month and a half ago, right? We still have the minus 9 plus 5 out there. Y is then x plus 3 squared. Because anything times itself is a squared, right? Plus negative 4. Right along. So let's compare that with vertex form. Let's compare with vertex form. Okay, here we go. X minus h, that means h is going to be negative 3. The vertex is going to be negative 3. And plus k, so that means h is, or yeah, k is going to be negative 4. So here's our vertex. There it is, negative 3, negative 4. Remember, when we get in this form, hk is your vertex. Let's plot negative 3, negative 4. I'm going to plot mine on the same one. Negative 3, negative 4 is right here. I'll put it in red. Negative 3, negative 4. Plot that with me. You can do it on a separate one or on the same one. It's up to you. Your notes. You don't turn in your notes to me. Negative 3, negative 4. You got it? Let's find the x-intercepts now. So I'll replace y with 0. Okay. So x-intercepts, here we go. So 0 equals x plus 3 squared plus a negative 4. Cool. Right? We're replacing y with 0 to find the x-intercepts. 0 is equal to x plus, actually, let's go and get rid of that 4, huh? So we'll add 4 to both sides. You get x alone now. So x plus 3 squared equals 4. We'll square root the right now to get rid of the second power and square root the left. So I have x plus 3 equaling positive and negative 2. 2 square roots of 4. So we have x then, subtract 3 from both sides. So x then is 2 answers. There's 2 roots. There's 2 x-intercepts. Negative 3 plus and minus 2. Right? Which is really negative 3 plus 2 and negative 3 minus 2. So x then is negative 1 and negative 5. Which means negative 1, 0, if we're going to plot the points, and negative 5, 0. Remember, y is 0. That's why we put y 0 right here. It's right there. This used to be y right here. Here's the equation. We replace y with 0, hence the points are negative 1, 0, negative 5, 0. Let's go ahead and plot those on our graph paper. So, negative 1, 0. There's another x-intercept, and negative 5, 0. Cool. So example 2 is in red right here on my board. Negative 1, 0, negative 5, 0. And here's a vertex for example 2. Okay. So let's do it. Now let's find the y-intercept. So y-intercept, let's replace x with 0 now. So y is equal to x plus 3 squared plus negative 4. Is it? Yeah. Okay, so let's replace x with 0 now. Y is 0 plus 3 squared plus negative 4. So y then is 3 squared plus negative 4. So y is 9 plus a negative 4. So y is 5, which means that's the y-intercept. That means x is 0 and y is 5. 0, 5. So let's plot our last point. We're ready to graph. We're ready to rock and roll. So right up here, 0, 5 is right there. Okay there? Got you. Here we go. So here's example 2. Here's a bigger parabola coming down deeper, coming back up. There's a y-intercept there. And yeah, I'm not sure what's going on over there, but if they bust through that wall and you get injured, don't sue me, okay? Please. Any questions on example 2?